Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this class, I would like to explain the problems on homogeneous differential equation and non-homogeneous differential equations and the problems on non-homogeneous differential equations. In the last class, we have seen how to solve the homogeneous differential equations and we have seen some problems also. Now I will solve one more problem on homogeneous differential equation. So this comes under method number 2. The first method already we have gone through as a variable separable method, and the second method is the homogeneous differential equation. Solve the differential equation y square minus xy dx plus x square dy is equal to 0. So clearly you can observe that it is a homogeneous differential equation because in each term of the given equation the degree is same, which is equal to 2. So y square, it is degree 2, and x into y, that is also degree 2 dx plus x square into dy is equal to 0. All are having degree 2, so it is a homogeneous differential equation. So in homogeneous differential equation, to solve the equations, we reduce into variable separable form by taking the substitution y is equal to vx. So first I will write the equation, given differential equation y square minus xy of dx plus x square dy is equal to 0. It is a homogeneous differential equation of degree 2. And degree 2 means each term is degree 2, it is a homogeneous differential equation. Now to solve this homogeneous differential equation, we have to take the substitute. We take y is equal to vx, so that dy by dx, on differentiating with respect to x, we will get dy by dx is equal to v plus x into dv by dx. So it is in uv form. V on differentiating x you get 1 plus x treat as constant term plus dv by dx, the differentiation of v with respect to x. Now the equation can be written as y square minus xy by x square plus dy by dx is equal to 0. Or what I can write, dy by dx is equal to minus of this one means I can write it as xy minus y square by x square. This is the given equation. Now on reducing this equation to variable separable form by using y is equal to vx. So the equation, the previous equation will get in the form, on the left hand side you'll get v plus x into dv by dx. v plus x into dv by dx you'll get on the left hand side, and on the right hand side x is same as x, so y you have to replace vx. So x into vx minus vx whole square by what is in the denominator, x square. So that also I am writing it is x square. So this is equal to, so what I can write, x square I can take common from the numerator, then it is v minus v square by x square. So x square also gets cancelled. V plus x into dv by dx is equal to, so the remaining term v minus v square only. Now it is plus v on both sides, so you can cancel out. Then what the equation will be, x dy by dx is equal to minus v square. Now there is a possibility of doing separation of variables. We can write variables v square on dv side and x variables on dx side, dx by x. So clearly it is in variable separable form, v square on dv side and x on dx side. So the equation becomes dv by v square is equal to minus dx by dx. So on taking integration both sides, on integrating, integral dv by v square is equal to minus dx by x plus log c or c, whatever it is. So integral dv by v square. So integral v power minus 2 dx or dv. So then what we can write, v power minus 2 dv. So what is the integration? V power minus 2 plus 1 by minus 2 plus 1, that is minus 1 by v integration. So this is minus 1 by v on the left hand side. So right side minus log x integration plus log c, or minus 1 by v is equal to log c minus log x, log m minus log n la undi. You can write log m by n, or c by x is equal to e power minus 1 by v. Or finally what we can write here? So c is equal to, I can write c is equal to x into e power minus, but what is v? What we have substituted? Y is equal to vx. So what is v? V is equal to y by x. So on replacing v is equal to y by x, e power minus x by y, this is the required solution of the given differential equation. So which it does not contain any differentials. It is a pure function of x and y. So this is the problem of solution of the given problem by using the homogeneous differential equation. You can solve the given problem in any model. We have 4 or 5 models to solve the first order and first degree differential equations. This is the one of the methods. So if the method is applicable, if the method is following the rules and regulations, then we can apply any method. So here I am solving this problem by using homogeneous differential equation method. So the next topic is non-homogeneous differential equation. So when we say that an equation is a non-homogeneous differential equation, an equation is of the form dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2 is called a non-homogeneous differential equation of first order in x and y. Here a1, b1, c1, a2, b2, c2 all are constants, where c1, c2 not equal to 0. c1 and c2 both are not equal to 0. If c1, c2 0, then what it means? It becomes a homogeneous differential equation. Then we can solve that by using the previous method. So if c1, c2 are some constants, not 0, then the equation is said to be non-homogeneous differential equation. So how to solve this equation? So to solve this equation, we can come across two types of cases. Case 1 is if a1 b2 minus a2 b1 not equal to 0. Or I can say that if a1 by a2 not equal to b1 by b2. Or I can say that a1 b2 minus a2 b1 not equal to 0. Where a1 is the x coefficient, b1 is the y coefficient, a2 is the again x coefficient, and b2 is the y coefficient in the denominator. So if you check the condition a1 b2 minus a2 b1, if it is not equal to 0, then we have to follow as per the following procedure. Substitute small x for x plus h and small y by y plus k, where h comma k are the constants to be chosen so as to satisfy a1h plus b1k plus c1 is equal to 0 and a2h plus b2k plus c2 is equal to 0. So h comma k are the solutions of the two homogeneous equations. So after solving the two equations, we'll get h and k. On substitution, you'll get small x and small y. So substitute small x and small y in the equation dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. Then the equation reduces to the form d capital Y by d capital X is equal to a1x plus b1y by a2x plus b2y. Clearly, this equation is looking like a homogeneous differential equation. Am I right or not? There is no constant in the numerator and the degree is numerator 1. The degree of the denominator is also 1. On cancelling out, the right side is a homogeneous function of degree 0. So this equation is a homogeneous differential equation. So we know how to solve the homogeneous differential equation. So by taking y is equal to vx, we can solve the equation for y and x. So after getting the solution, we finally replace capital X for small x minus h, because we have taken initially small x is equal to capital X plus h, small y is equal to capital Y plus k. So capital X will become small x minus small h, small capital X becomes small x minus h, and capital Y becomes y minus k. Finally, on substituting these, we will get the required solution. So if the given equation is a non-homogeneous differential equation and a1 b2 minus a2 b1 not equal to 0, then we have to follow this procedure. Suppose what is case 2? If a1 b2 minus a2 b1 is equal to 0, or a1 by a2 is equal to b1 by b2, or I can write the same thing as a1 b2 minus a2 b1 is equal to 0. So if a1 b2 minus a2 b1 is equal to 0, then our given differential equation can be written in this form. dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y. a2x plus b2y can be represented as m into a1x plus b1y. If a1 b2 minus a2 b1 is equal to 0, in this case, a2x plus b2y can be represented as m into a1x plus b1y. So on writing like this, the equation can be solved by substitution method. So here a1x plus b1y plus is equal to t. We take the substitution a1x plus b1y is equal to t. Then the total equation will get in the form. So what the equation will get in the form? dy by dx is equal to, if you replace a1x plus b1y is equal to t, this gives t plus c1 by some constant m into t plus c2. So clearly the right side, the total function is a function of t, and dy by dx is replaced by, here y is equal to a1x plus b1y plus is equal to t means a1 plus b1 dy by dx is equal to dt by dx. Or what I can write, b1 dy by dx is equal to dt by dx minus a1, or dy by dx can be replaced by this by b1. So dy by dx can be replaced by here 1 by b1 into dt by dx minus a1. That means what? The entire differential equation will get in the form of variable separable form. So there are only two variables, t and x, and remaining all are constants. So on separating the variables and on integrating, we will get the solution. So we study here two cases. The case one is if a1 b2 minus a2 b1 not equal to 0, then we use the substitution small x is equal to capital X plus h, small y is equal to capital Y plus k, where h and k are determined to satisfy the two equations. Then the total equation, differential equation, reduces to homogeneous form, and it can be solved by taking y is equal to px. Finally, we replace capital X by small x minus h and capital Y by small y minus k. So if the case 2 is if a1 b2 minus a2 b1 is equal to 0, then the differential equation will write in the notation, given notation dy by dx is equal to that notation as seen on the board. And this equation can be represented as a variable separable form by taking a substitution. So this is the procedure to solve the non-homogeneous differential equations. So now we see some problems on non-homogeneous differential equation and how to solve these equations based on the given condition. So I will see the first problem, that is solve the differential equation dy by dx is equal to x plus 2y minus 3 by 2x plus y minus 3. Clearly it is in the form a1x plus b1y plus c1. What is the notation? Dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. Here what is a1? a1 is equal to 1, b1 is equal to 2, c1 is equal to minus 3. And what is a2? a2 is equal to 2 and b2 is equal to 1 and c2 is equal to minus 3. So what is the condition? a1 b2 minus a2 b1. So what is the value? a1 b2 1 into 1 minus a2 2 b1 also 2. That means 1 minus 4. This is minus 3, which is not equal to 0. That means what? This is comes under case number 1. So to solve this equation in this method, we take the substitution x is equal to x plus h and y is equal to y plus k, where h comma k are the constants to be chosen so as to satisfy the equations h plus 2k minus 3 is equal to 0, 2h plus k minus 3 is equal to 0. So solve the two equations. You know how to solve the two equations. H plus 2k minus 3 0 and 2h plus k minus 3 0. So multiply second equation with 2. You'll get what is the equation will become 4h plus 2k minus 6 is equal to 0. So I'm solving the two equations for h and k. If you know h and k, your substitution will be confirmed. Small x is equal to capital X plus h and small y is equal to capital Y plus k. So on subtracting, this will get minus 3h and 2k will get cancelled, and this is plus 3 is equal to 0, or 3h is equal to 3, h is equal to 1. So that is our h value. H is equal to 1. So on putting h value in the one of the two equations, in the first equation what we will get? 1 minus 3. 2k minus 2 is equal to 0 and k is also 1. So k also 1. So our h and k obtained. So on substituting, small x is equal to capital X plus 1 and small y is equal to capital Y plus k means 1. The equation reduces to the form dy by dx. Now the equation turned into all capital letters because we have taken small x and small y for capital X plus 1 and capital Y plus 1 respectively. So the equation reduces to form dy by dx is equal to x plus 2y by 2x plus y. So to solve this equation, clearly it is a homogeneous differential equation. So to solve this equation, we take y is equal to vx. So I'll go to the next slide. So we take the substitution y is equal to vx. Then what becomes dy by dx? V plus x into dv by dx, as we have seen in the homogeneous differential equation solution. So here the all letters will be in the capital letters only. And equation 2 becomes, what is equation 2? This is equation 2. dy by dx is replaced by capital V plus x into dv by dx on the left hand side. And on the right hand side, x plus 1, right? We replace y is equal to vx. So x plus x plus 2vx. Am I right? X plus y, in y we replace vx by 2 into x plus y means vx, 2x plus vx. So on taking out x in the numerator and denominator, we will get 2 plus v by 1 plus v. Here we will get v plus x into dv by dx is equal to 2 plus v by x cancel 1 plus, sorry. This is 1 plus, in numerator 1 plus, this is 2v by, this is 2 plus v. So on writing v on the right hand side, so this v will go into the right hand side as minus v. Then what is LCM? 2 plus v, and here 1 plus 2v minus 2v minus v square, and this will get cancelled, and it is 1 minus v square by 2 plus v. What this is? X into dv by dx. Am I right? X dv by dx is equal to 1 minus v square by 2 plus v. Now, this equation, clearly it is in variable separable form. There are only two variables, v on the right hand side, x here. So there are two terms, dv and dx. Now on separating the variables, I can write it as 2 plus v by 1 minus v square dv is equal to dx by x. So that equation we obtained here, 2 plus v by 1 minus v square is equal to dx by x. Now to find the solution of this, we integrate both sides. Then integral of this one is equal to integral of this one plus log c. So integral 2 by 1 minus v square. So that is log 1 plus v by 1 minus v minus 1 by 2 into log 1 minus v square is equal to log x plus log c. So finally, this on simplifying and putting capital V is equal to capital Y by x. V is equal to, y is equal to what we have taken? Y is equal to Vx. Then what is V? V is equal to Y by x. So on substituting V is equal to Y by x, the entire equation will gets into the form capital X plus capital Y is equal to C into x minus y whole cube. Now replace capital X for small x minus 1 and capital Y for small y minus 1. So in this equation we replace x minus 1. I will show this the final solution. Here I can write small x minus 1 plus small y minus 1 is equal to C into capital X small x minus 1 minus small y plus 1 whole cube, or 1 what is on the left hand side? X plus y minus 2 is equal to C into x minus y minus 1 plus 1 gets cancelled whole cube. This is the required solution of the given differential equation. So this is the method of finding the solution of a non-homogeneous differential equation. So this is the equation. This is a non-homogeneous equation clearly. To solve this equation, we reduce to the form small x is equal to capital X plus h and small y is equal to capital Y plus k, so that the equations reduces to homogeneous form. And this homogeneous differential equation can be solved by taking y is equal to vx. So the entire equation will get into the variable separable form, v variables dv side and x variables dx side, and on integrating we will get the required solution. So in the next class we see some problems, the remaining problems in non-homogeneous differential equation, and then we go for the another method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.